Hello, everyone. This is Nick, and this is Postgres TV, the third episode of Postgres TV, our online show, which is supposed to be happen bi-weekly, so every second Thursday. And with me, Ilya, my co-host. Ilya, hello, Ilya.
Hi everyone.
And we have guests.
Yeah, we have two guests today, and those are Stephen Frost and David Steele. And probably based on that, you can guess our topic. That would be not about I don't know, drinking beer in pgCon. It would be about pgBackRest. So nice and interesting piece of backup software.
One of the most popular backup solutions for Postgres, right? Competing with others, of course, I think we will discuss it today, comparison to other products. But definitely pgBackRest is one of the most popular tools right now, right? And before we proceed, I would like to show a couple of links and announcements just to this is what we usually do. Just it will not. Yeah, in the beginning. So we have document. I just created it recently. I'm going to share screen for a minute or two. So this is our document, and it has a short link, bit.ly Postgres TV. So this document is our agenda, and with question ideas, anything, and commenting is open. You can propose your own ideas for future. You can propose questions and so on. And of course, you always can join our Zoom sessions. I'm posting Zoom links here right before the event, just to avoid spam and so on. And you need to be registered in Zoom to do it. Or you can go to YouTube and also watch it there. And we will monitor during our call. We will monitor YouTube chat as well. So this is first link. Second link, if you go to our YouTube channel. Oh, it's not here. So we have a short link. It's just Postgres TV, Postgres TV. If you go there, it will redirect you to YouTube. And we started to collect various videos which are published in YouTube. So if you go to playlists, you'll find various collections. And it's already more than almost 300 videos in various like placed to various topics. So you may find convenient if you're interested in particular topic. And of course, you can find Postgres backups, and a lot of videos here are related to pgBackRest as well. And finally, my team, my small team, Postgres AI team, is working still continue to work on database lab, and we are going to release the second version soon. So in our document you can find a link. This is a product which helps you. It has open source part and enterprise edition part. You can register and join to our event where we will discuss what we recently created and how Database Lab can help you to build non-production environments to speed up development and testing and SQL optimization and everything. So this is quite interesting because I'm personally attached to this topic already a couple of years, and we have very interesting case studies already in large companies. So we are going. I invite everyone, and we will just go to this link. You will need to leave email, and we will send you personal invitation to our call, and you will be able to discuss details directly with us. That's it.
It looks like, according to our chat, Database Lab is much less popular as Steven's bird.
Yeah, of course.
In chat, it's like 100% success, Steven.
Yeah, bird is cool. Cool.
So glad to hear that.
Yeah, that's it with announcements. So let's switch to our topic, and I will let Ilya today to have leading role in our in asking questions, because
I like backups, and
Yeah.
moreover, I like to restore from backups sometimes.
But expect difficult questions from me as well.
Yeah, we try our best because backups is important topic, and we'll try to get a lot of inconvenient questions. Just first thing first, a small introduction. So for many people, you both do not need to be introduced in any way, but just a couple of words. You're both working for Crunchy. How you get to Postgres, to open source, to Crunchy, what Crunchy is, just to get familiar with our today's guests. Stephen, start with you.
Sure, I'm happy to start out. I've been working with Postgres for, 15 plus years now at this point. I actually started out working with Oracle, as you do, right? And was looking around for some open source alternatives because I really enjoyed working with the Linux kernel and with Debian, actually. So I was a Debian developer before I started getting involved with Postgres, but that's kind of how I found Postgres, and now I been involved in it. In terms of Crunchy, I'm the Chief Technology Officer here at Crunchy, and I've been involved, I guess, about 6-7 years now, something like that, quite a while. And was happy to be brought on board near the beginning of Crunchy. We've continued to grow really well, and are very, very happy with how things have been going.
David.
Great. So yeah, I'm David Steele. I've been working with Postgres actually since 1999. I started on the last 6, whatever the last version of 6 was, but I didn't deploy anything on 6. But at that point, I was just really a hobbyist. I was using it for personal projects. I still have a mail server that I wrote that's based on, backed by Postgres. So I didn't really start getting into it professionally until around 2010, so about 10 years ago. And just, again, I have a strong Oracle background. I'd done SQL Server work, but I was looking, Postgres had really gotten to the point where I felt it was a direct replacement for these databases. And, why not just save all that money? At the time, because I was working with really large databases, I selfishly wanted to spend all that licensing money on hardware. So the idea was if we could get Postgres running, for our data warehouses and stuff, then we could spend all that budget on hardware and not pay any on licensing. So that was the goal there. And I've been at Crunchy now for 5.5 years. Stephen and I worked together previously, so it's not a complete accident we're here together. And most of my time here has been spent working on open source software, primarily pgBackRest, of course, also PG Audit. I've also been a Postgres contributor during that time as well, and minor contributions to other projects. So it's been great.
So the question which I actually intended to ask, so what we know, if we type Crunchy data in Google and get to a website, it's like company which works with large enterprises. You both doing lots of community stuff. So pgBackRest is open source. Steven runs things in PGUS, organizes committer for PostgreSQL community. How it works together? So basically, usually we used to have an impression that large companies, they are for profit for large enterprises. How Crunchy works with community, how it works together.
So I would say that Crunchy works in a manner very similar to Red Hat, right? We are very much committed to open source and to open source technology, and so the way that we operate with our clients is through kind of a support subscription model. Again, very similar to Red Hat and their model, which obviously has been quite successful, and we've had great success with that too. So we really are very committed to open source. All of our contributions go to Backrest, to Postgres, are all made through open source contributions and improvements to the core code. We have 4 committers who are working quite diligently on Postgres projects, including Tom Lane, myself, Joe Conway, and Peter Gagan. And I tell you, Peter's done some fantastic work around improving our B-tree indexes in Postgres, which has been really phenomenal. Our other projects, things like our containers project, is also open source and available. People can go look at it, and we have lots of people who use our open source operator inside of their Kubernetes environment. It's all available, and people are certainly welcome to go use it and play with it. And so again, we follow kind of more of that Red Hat model. So that's how Crunchy works and how we've been very successful. So we're very committed to open source.
It's interesting. So it looks like you solved like dilemma. Like, for example, you have a feature which you are going to add, and you think, should we add it to open source, or it should be like some additional extension, an enterprise version, and so on. So it looks like you solved dilemma like 100% open source, right?
That's correct. Yeah, we don't have any. Yeah, we don't go and try to have some kind of locked-in commercial version. It's one of the big differentiators, I would argue, between us and some of the other organizations out there, that they all have this question of, do we develop a feature for our enterprise, our special version of Postgres so that we can try to lock people in, or do we just work in the community and try and contribute back? There's no question at Crunchy. Everything goes to open source Postgres.
I would say, another thing is that it's actually a huge advantage for everybody, because the features get released into the community. They're kind of vetted in the community as well as with our customers, and you just get a much wider base of people who are looking at this feature, playing with it, suggesting improvements for it, et cetera, et cetera. We've had a lot of success getting people in the community to do testing of new features or performance improvements for us, and so it's just a fantastic resource to suggest features, test features, make features better, all this kind of stuff, and everyone benefits. Crunchy benefits, our customers benefit, and the open source community as a whole benefits. So it's really win-win.
It's a usual question in such case which I ask. For example, pgBackRest, it's quite a huge project. Do you have any active members who develop pgBackRest but do not work for Crunchy? So some external contributors. So it's like, is it more than?
So yeah, we do. We have a couple of them. I think David might be able to talk more to this, but certainly Stephen Frost is one who has been contributing feature development as well as doing reviews of code that like David will write some feature for pgBackRest, and then Stefan will come and review it. So yeah, we do have external contributors. We have some kind of drive-by contributors as well, and then we've got a number of people who are not currently, Crunchy subscribers or clients of ours who have been doing things like benchmarking work. In particular, there's one group out there that's particularly interested in small file performance, and they've been helping us by doing a bunch of benchmarking work. So it's much more of a community project than something internal, right? I'll also point out, because this is a common misconception, pgBackRest was not started by Crunchy. Okay, pgBackRest was actually started back when David and I worked for a company in the ad tech space called Resonate. That's where pgBackRest actually
so it's
started.
Quite a long time ago.
Oh yes, it was before David and I were at Crunchy, and part of the reason that Crunchy reached out to David was because when I joined, I was like, you know what we need to bring David on, because he's doing great work, not just in Backrest, but in Postgres in general. As mentioned, he's been a contributor to the Postgres project also, and has a number of patches contributed, and so that's how I was able to bring him on board. And it kind of naturally fit that Backrest would become what we ended up using, because that's what we were using back at Resonate. We were developing it, and so we continued to develop it, and it's come really a long way. But Backrest has been around for quite a long time, and it was started out as an open source project right from the get-go, really.
That's another interesting question, because we are talking about old good times. Then pgBackRest was written in Perl, if you can call that a good time. But I like Perl, maybe like David does. But the question is, that time then you started to use Postgres, but just before pgBackRest. What was the landscape? How do people were backing up Postgres at times? With which backup solutions did you start it?
I think as many do, with homemade scripts, right? So at the time, we evaluated some different options, but there weren't any options out there that were able to do parallel backup. And that was critical
With
for us,
compression
right?
on top of that.
In our environment. Yeah, with compression on top
So
of
a
that. Yeah, in
large
our environment.
database, etc.
Oh, yeah. Yeah. We had
Well, we were
what was
working,
it? I think it was around, yeah.
it was around 50 terabytes of databases. That wasn't in a single cluster. Our largest single cluster, as I recall, was 14 terabytes. But still relatively substantial, and all combined, we really needed parallelism to keep up with everything, and we needed compression. So getting those two things together at that time just wasn't possible. So we were looking at possibly contributing to something to try to introduce those features, but it came down to an architectural question for us of the what those other products were based on and how they were working, and we felt that it was too heavy a lift to try to actually change the way that they worked enough to give us parallelism and compression, which is what we really needed to keep up with 50 terabytes of data, rapidly changing data as well. So we had extremely high wall volumes.
So it's basically, it was like real need to implement such crazy idea, crazy for many people. Like you invented your own protocol, if I'm not mistaken. So basically, it's like
Yes.
very, very specific approach. So I just trying to imagine, then you started to advocate this idea. What was your first arguments? I written this in Perl and it's custom format. People do use this. Was it easy to propagate pgBackRest at times? Then you started this.
Well, it was the project was open source from the very beginning, but I will say that the initial requirements were all outlined by what Resonate needed in order to back up this 50 terabytes worth of data and safely be able to do restores, build our dev environments, all that kind of stuff. So that was really our initial requirements. I'm not exactly sure what you mean by custom format. Are you talking about the repository format?
I mean that pgBackRest do everything but on itself, so it doesn't use
that's true.
pg-based backup or things like this.
The reason is that basically the tools that were typically used for backup, like pg-based backup and rsync, rsync itself has some issues with doing backups, incremental backups in the first place, which is sort of a different topic. But I have demonstrated at conferences how rsync is not safe for incrementals unless you turn on checksums, and then it's fine, of course. But so what we realized is the specific problems that we need to solve, there really weren't tools available to do that. So, hooking together a bunch of command line tools really wasn't going to work. And we wanted everything to be streamed in memory, so we don't use any temp files, we don't spool anything. When we're transferring files to a remote host, it just goes straight through. We have buffers, of course, so we're taking a buffer, compressing it, transferring it, that kind of things. So, but to get the level of performance that we required, we found that we really had to do it ourselves. Now, of course, we're not, re-implementing gzip, LZ4, all that kind of stuff. We use libraries whenever possible. Same thing with encryption, and we haven't rolled our own encryption. We're using SSH for our transport, so we didn't re-roll our own encrypted transport, et cetera, et cetera. So where possible, we use tools and libraries that were already available. There was no incentive to reinvent the wheel for the sake of reinventing the wheel. That's not what we were going for. But we knew that certain, backup specific tasks just had to be done outside of the common tools that had been used to do that in the past.
Great. It's
And
quite interesting.
Since you mentioned several features, what about compression? How like what kind of compression is supported? Can I change it in the control level of compression and so on?
You can. So currently we support 4 different types of compression. It depends a little bit on your platform because they're not all available on all platforms. The 2 that are always available are gzip and bzip. So you'll always find those in pgBackRest on any platform. The optional ones are LZ4, which shows up almost everywhere unless you're on a pretty old distro. And then the newest one we added was Z standard, which unfortunately is not available everywhere just because the library is not available on all platforms. For instance, RHEL in particular decided to only make that available on Apple. So, but I believe the community packages are actually requiring Apple for pgBackRest now, so Z standard is built in. Those are the 4 we have. For archiving, you can change your compression whenever you want. Just on the fly, you can just change the compression, it'll start compressing in that new format. for backups, each backup set has to be in the same compression format. So if you change the compression format, what will happen is you'll get a warning that's saying, I'm going to change this back until the next full backup, right? So if I was doing gzip and I want to go to Z standard, the easy thing to do is the night before your full backup, change it to Z standard. Or if you don't mind getting 1 or 2 warnings, it continues to work. It just says, I'm changing the compression back. This will take effect on the next full backup. So that next full backup would then be Z standard, and then that backup set is Z standard, and then you're on Z standard from then on. It doesn't matter what any of your old backups are, with the exception that if you pick one of the new compression types, and then you go back to a pretty old version of pgBackRest that didn't support that compression type, then you're going to get an error when you try to restore, because it's just not going to understand it. And we do have this caveated in a release notes to say, hey, these new compression types are great, but it does essentially break the repo format because, you know, the older versions of pgBackRest won't understand what this is, and you'll get an error.
Since you touched the topic of old, new versions, etc., how difficult is actually to keep up with changing Postgres while you develop in pgBackRest all those years? Were any problems, or it was just flawlessly?
Some versions are harder than others. Postgres 12 was a pretty massive change when we got rid of recovery.conf and put all the recovery settings into postgresql.auto.conf. That was a pretty big change for us. And worse, it happened right at the point where we were finishing up the C migration, but we hadn't migrated restore yet. Restore was second to last and backup was last. So we kind of didn't get, you know, we basically barely got that out in time, you know, for right before Postgres 12, because we didn't want to write it in Perl and then rewrite it in C. So we just wanted to write it in C. Most years haven't been that big. And actually a lot of the changes that have made to backup have been driven by patches I've submitted or things that, you know, I've done with Magnus. So these were things I was doing in general to try to make things actually easier. So even though it was a change, it was actually making backup easier for coding, for the users, for kind of everything. And because we're not a simple script, I mean, this is a fairly large piece of C code now. And so dealing with multi-version stuff is not that big a deal. We do it all over the code. You know, essentially, if the stuff that's common to every version, then if it's greater than or equal to PG12, do this, you know, et cetera. So we have those types of exceptions, and they're all over the place. And we have testing, you know, test coverage for all of them. And we test against extensively against every version of Postgres that we support, all the way down to 8.3. So, you know, if something comes up that's version specific, we see it really quickly.
That's interesting. You mentioned that at some point you decided to switch to C. I'm pretty sure it was like, I have a couple of guesses why you did this, but still, why? Is it Perl not fancy enough?
I'm gonna let Stephen at least start on this one.
So there were a couple of different reasons why we wanted to move to C. I would say one of the first reasons that we were considering a migration to C was because frankly the Perl performance was not where we wanted it to be, which may sound a little odd because generally Perl can be pretty performant, but it's actually it's interesting.
Memory,
you can try your hardest. Well, you can try your hardest to try to get Perl to load fast, but at some point, kind of there's this baseline 100+ milliseconds that you're going to be waiting for that interpreter to start up and run. And that just wasn't acceptable for us on very high throughput systems where that archive command was being called over and over and over again. So we needed something faster than that. It was then the question of, okay, well, do we go to C or do we do something else, right? Ultimately,
you have
we ended
already
up
5 or 6 suggestions in chat. People asking you
Rust, go.
Python, go.
So we did consider going to other possible languages, but at the end of the day, we want to take advantage of being close to Postgres in a lot of ways, and naturally Postgres is written in C. So we already have some cases where things like the control file that Postgres creates, right? We read that out, right? We figured out ways to read that out with Perl, but it gets a little bit complicated because there are certain things that are platform dependent, you know, and it depends on whether, you know, you compile this way or compile that way. So by making sure that we use the same kind of loading logic that that Postgres itself does, we're able to work around that. And I think there's going to be more of that coming. I'm sure of it because it's all in the backlog. In particular, what we'd like to do is start reading the actual write-ahead log, right, and being able to pull things out of the write-ahead log. And we want to be able to leverage the Postgres C code that's already written to do that. Now, we're probably going to end up rewriting it, but we'll be able to pull in some of the structures at least to allow us to use that. And that's just going to be easier to do in C than it is in Perl. So there was performance considerations. There were considerations for getting closer to Postgres and to the Postgres project. And I think also we want more contributors. We want new contributors. And while, yeah, maybe we could have gotten Go contributors or we could have gotten Rust contributors to come and join us. The reality is that people who use Postgres and are contributing to Postgres are writing C code, right? In many, many cases. And therefore, for us, it made a lot of sense from a potential contributor base to go to C as well.
Is there more? No, normal C or pgBackRest is like Postgres. Postgres is written in Postgres C, so it's slightly different knowledge. Is pgBackRest written in Postgres C or pgBackRest C or just C?
I'm not sure that I completely understand that question. I mean, we're a C99 project, so everything is standard C99.
So I think I understand where he's coming from, right? And I would argue that it's actually, to some extent, it's pgBackRest C, right? So just like Postgres has things like memory context, right? Exactly. We have similar concepts in pgBackRest that are not the same. Although if you've been working with Postgres and you come look at and work with pgBackRest, you'll see a lot of commonality, right? Because we took a lot of inspiration for things like memory context and error handling and things like that from Postgres, because obviously Postgres does a great job in a lot of those areas, and we wanted to leverage that. So there are differences, right? It's not exactly the same as writing Postgres C code, but certainly I would argue that it's probably one of the closer projects, right? I think it's, if you wanted to go look at the curl code, right? The curl code is not the same as Postgres code. It's got its own ways of doing things, whereas pgBackRest, yeah, it's different, but it's really pretty similar to Postgres C in a lot of ways.
There are a lot of commonalities, and we have taken a lot of inspiration from Postgres. We even do say sometimes, WWPGD, what would Postgres do? So if we're trying to solve a particular problem and it's already been solved in the Postgres code base, we will go and look at that for inspiration. We may not be able to pull the code directly, because our memory management is a bit different, our error handling is different, but we can definitely look at the code base. A great example of that is the new TLS implementation we did over the summer, the async TLS implementation. Very heavily borrows from Postgres, enough that in the header file it states that, that it was heavily pulled from Postgres. It's not the same code, but I did really look at what Postgres had done, because this is battle-tested code that's been used by millions and millions of people around the world. So if there's something in Postgres that we can use, we're going to go grab that. Another great example of C code we grabbed from Postgres early on was the checksumming code, to be able to calculate page checksums for in the backup, and implementing that outside of C is tough. And other projects have just punted on it because it's too hard to translate into another language and make it performant. So they just haven't. But by being able to take that C code directly and apply the loop unrolling and the vectorization optimizations that are required to make it fast, we get all that for free. Just and that one we really did just copy. It's pretty much a direct copy of what's in Postgres.
Wasn't the option just to include it somehow, not to copy, but dependency, right? So it's better to copy. I mean, if
we've
not
talked about that.
Oh, okay.
Yeah. I right now we don't depend on Postgres. We've talked about leveraging the libpg common, which is the static library that Postgres does provide that we could potentially link in. We've thought about it. I would say that we primarily haven't, for two main reasons. Reason number one is that it's not like actually used that much outside of the Postgres project. There aren't a lot of other projects that leverage it today. And so, you know, some of the interfaces are just not very good for using from an external project. I'd honestly like to fix that as a Postgres person and as somebody who wants to work on Postgres, but there's another side of it, which is that every single line of code in pgBackRest has tests written for it. We literally have 100% test coverage of every line of code, and I think every branch or almost every branch through that code.
Every branch and every condition in every branch. So every Boolean condition is tested for every branch and every line of code and every function.
So in some sense,
on each git
Postgres is
push.
ahead of Postgres in that regard.
On each git push,
yes, absolutely.
I checked you use Travis CI, right? You use a Travis CI to automate testing. So every git push launches.
Absolutely.
The chain
we have really extensive testing. Another thing that Stephen, maybe he was going to mention, but the reason why we actually pull code from Postgres rather than trying to link directly to, say, the newest version of Postgres is we support now 12 versions of Postgres. And the rate of change between Postgres versions is actually high. The wall headers change. The PG control changes almost every version. Not only does PG control change, but the data structures that go into PG control change. So if we link against the most recent version of Postgres, we could grab the checksum code out, right? That one really hasn't changed. But how would we read PG control from 8.3? You know, Postgres 13 won't read 8.3's PG control file. It has no knowledge of it. So what we've come up with is a versioning system where each version of Postgres, we can pull out the data structures that have changed. And then based on the version, we basically recombine them into a coherent looking piece of code for that version of Postgres. And then we build 12, 13 different versions of that. So we're able to see that snapshot of Postgres as it was at that time for 8.3 through Postgres 13. So we can work with all the Postgres data structures natively as they were at that time in that release. And that's one of the biggest reasons. So if we really wanted to use Postgres like libcommon, we'd have to teach Postgres how to read old versions of PG control, how to read old versions of wall headers, how to read old versions of all this stuff. Some of that might fly in the core project, like having PG control data read old PG control files might actually be considered a pretty cool and worthwhile feature to have in Postgres, but not all of it. Reading old wall files, that might be a tough sell. So that's one of the reasons why we don't link directly, because we want to have support for all these versions and we need to pull the data structures and combine them in the right ways to make that work.
Right.
We have that really, sorry. I just want to say that really, you know, all of that discussion really dovetails into the discussion about, it kind of leads to backrest in core, right?
Right.
Which is something that I've always thought of as like
we're going around.
This is what I wanted to ask you. Sorry, I will interrupt a little bit. I wanted to ask you differently. Like, do you think that Postgres core functionality will develop towards like covering the same kinds of features that pgBackRest provides, and also maybe at some point, since pgBackRest and C, maybe Postgres will start copying some parts of code at some point. This is my question.
So I think it's a possibility that certainly there's been activity in the core project for adding in new functionality because people see the limits of pg-based backup and some of the other tooling, right? So there's been work going on to implement parallelism, for example, in pg-based backup. Part of the challenge there, though, is that you have to do some of these things together, right? So the first thing that pg-based backup, and this is something that we actually get involved in on the list of trying to share our knowledge and our experience working with pgBackRest back to the folks that have been working on improving pg-based backup, that you had to go develop a manifest. So the manifest feature that exists in pg-based backup is, I would say, at least somewhat influenced by pgBackRest in the fact that David and I were involved in that conversation about adding that capability. Yes, I think there's work going on to add this capability into core. I don't know when core is going to get to that point, because honestly, it's exactly the same reason in a lot of cases, you know, in that for pgBackRest not being in core is because we support all the way back to 8.3, right? Anything that's going on in core is obviously only going to work with newer versions of Postgres, right? it's not going to work with older versions of Postgres. So you immediately have this case of, well, that's a great new feature, and if I'm on version 15, I can use that. But if I'm not, and I've got a heterogeneous environment where I've got 5 different versions or possibly more of Postgres that I'm working with, it's not going to be helpful to me, right? And even then, the fact that you only get new features every year, I think, is another challenge, right? pgBackRest has been moving forward at a much higher clip than the core project has been in terms of when we introduce new features. We do so almost every other month, right? And maybe even more frequently, right? Sometimes, but that's important to be able to move the project forward and to get people able to leverage those new features. And it's just a different kind of cadence. Maybe at some point it's going to change. I think that there is a possibility that at some point the cadence of pgBackRest will slow down and become something that maybe will end up being more like the Postgres cadence. But certainly I don't see that in the near future. There's just too many things and too many opportunities and too many new capabilities we want to bring to pgBackRest to have it be at that kind of a yearly pace right now.
Makes sense. Yeah. Ilya, you wanted to?
I just wanted to move a bit towards how pgBackRest works conceptually, because people are keeping asking quite specific technical questions. So maybe we start digging through that path, and probably you'll like that as well, I think. So pgBackRest, what is it architecturally and conceptually? So what it is Stanza, why Stanza, why do not call that something like configuration file or catalog or something like this? How you get this idea and why it is like this? So
well, Stanza is just I mean, we had to come up with something to call so a stanza in the tech world just means a group of configuration or a group of code, a related group. And we didn't want to use the word cluster because cluster means something very specific in the Postgres world. Cluster is what other people might call an instance. In fact, I prefer instance much better. But in Postgres, it's called a cluster. And so when you're dealing with Stanza configuration, the Stanza is actually addressing multiple clusters, a primary and some number of standby clusters, and which might be in flux. So the thing that's the primary today might not be the primary tomorrow. Those things are going to move around. And so it needs to be very flexible in terms of, okay, you've got a list of Postgres clusters in the Stanza. And when I go to do a backup, I'm going to go talk to those Postgres clusters, figure out who's the primary, figure out who's a standby, that kind of thing, so I can do my backup. So Stanza is a collection. Yeah,
sorry. Or for example, we changed encryption keys, encryption key rotation, right? Yeah. Is it a good example in this context or no? Like
well, the encryption keys are really related to the repository itself. Okay. And the repository is not really in that Stanza configuration. The Stanza is related to each collection of clusters that you're going to be doing backup and restore to. So when you're talking about the encryption on the repository side, that's a bit different. Key rotation is an interesting topic because we actually do key rotation internally. People do occasionally want to be able to change their master keys as well, which is a totally reasonable use case. And it's fairly easy to do because all of our stuff is OpenSSL compatible. So you can just use the command line tool to change your keys. But inside those main info files, we also have subkeys, and then for the backups, we're rotating keys with every backup set, et cetera. So there is key rotation going on. So you don't need to rotate keys for that sake, unless you just happen to want to change your master key for security purposes, which is totally reasonable, of course. And we encourage people to, the way you handle security is mostly up to you. We're just giving you the tools to help you do it.
Right. So, it's totally possible to, very simple question, because I'm not a user of pgBackRest right now, but question, is it possible to get full backup from a replica? Of course, it should be possible, right? I don't know.
Yes, but the method we use does actually require communication with the primary, because we start and stop the backup on the primary. So what you end up with is the vast majority of all the files are copied from the standby. Everything that's replicated is copied from the standby. But we do pull stats from the primary. We pull the configuration file from the, configuration stuff from the primary. We do start and stop there so that you get a wall segment pushed out at the end of the backup. so you know that your backup is complete at the end,
Right.
you know, et cetera. So you basically get a primary style backup while copying virtually everything from
Cool.
the standby.
Like not loading primary disks, right?
Not loading the
because
primary.
it's the most important.
Right, but you do have to be able to talk to the primary. So we only copy a few things from the primary, but we do start and stop the backup there.
And you
as
say
well.
you said the configuration file, so you consider configuration as a part of backup, like
I don't really. I a lot of people do like having those, you know, like Postgres.conf, you know, backed up as part of their backup. I'm more of a configuration management type of person. I want to see all those things rebuilt on the new host and other things like that. But again, different people have different styles of doing things. So if it's in the Postgres directory in pgdata, you know, we're going to copy it. So
yeah, it depends
you know,
on the platform. Like on Red Hat,
right.
it will be there, but on
And we've
Debian,
also
it will
done
not.
a lot. We've also done a lot of work making sure we work with perfectly symmetrical configurations. So the idea is you can take the primary config, put it on the standby, and from a pgBackRest standpoint, that's going to work just fine. Now you may need different, you know, memory settings, buffer cache might need to be different and things like that, but that's really your responsibility to figure those things out. And maybe you can do that in postgres.auto.conf. I mean, there are a variety of ways to do this, and we're not really involved in configuration. Right. So it's up to
am
the
I
user.
correct that it could be like in the next couple of years, it would be some combined sort of pgBackRest would be not only backup tool, but like Kubernetes itself or tool like Kubernetes and some configuration management tool? Or you do not plan to bring such functionality?
I hope not. I mean, we're not planning to go that far with it. I mean, you know, at a point, pgBackRest will get smarter about things. Like we'll be able to say schedule backups instead of doing them through cron. You know, we'll have an awareness of the cluster as a whole and be able to schedule a backup on a node that is lightly loaded or is definitely not the primary or things like that. These are things right now that the user has to manage, you know, where the backups are actually going to be made from. So I can see us expanding into that space of trying to, you know, make the configuration management overall, like basically you hand backrest a list of the hosts that it has control of, and it goes and manages backup on those hosts, archiving, backup, all that kind of stuff. So I can see it going that far, but no further than that. We don't want complete control. and we're not really looking to be an HA you know, product either. There are good HA products out there that we work with, but we're not looking to move into that space of HA. It's its own huge space, and you know, other people are doing it very well. So we see no need to resolve a problem that's been solved adequately.
Right. So if you do full backup from a primary, it's easy. But if we want to do it from a secondary, we need to code some logic to choose which node should be used, right?
No, we do that.
No.
How do you?
Yeah. So the way Postgres, the way pgBackRest works here, and what we encourage everyone to do is have the same pgBackRest configuration on your primary and on your replicas, however many replicas you have. And then when you run the backup, pgBackRest will actually connect to all of them, figure out which one is the primary, figure out a standby that's available. And if you tell it to, we'll do the backup from the standby automatically.
But who will choose which standby to use if I have, for example, 5 standbys?
Basically, right now, pgBackRest will pick the first one, right? What David was just alluding to is that what we would like to do is get to a point where we can actually tell through some metric or something which standby would be the best one to do the backup from, and then we will use that, right? But at least currently, it's the first one that's available, right?
Right. And in addition, one of the reasons why we developed the backup method that we did is ultimately we would like to be able to spread the backup among multiple standbys. So if we use the standard Postgres method for backup from standby, then you're still limited to backing up from one standby. But the way we did it, where we're copying replicated files from the standby and non-replicated files from the primary, we can now spread the work of I mean, we still have to copy the same stuff from the primary. There's really no getting around that, but it's a very small amount of data. And then we can spread the work across the standbys, you know, as far as you want.
never heard or thought about this idea. So like parallelization on host level, like, right? So we not on CPU level, but further on host
if
level.
you have 15 terabytes or more, you probably can have problems with network, for example.
Yeah.
Between your backrest and
it's easy to load a network with pgBackRest. Boy, it's so easy, especially a 1 gigabit network. My goodness, you can fill that like without even really trying very much. Yeah,
Can you throttle yourself? Like say I don't want to go to like more than half a gigabyte per second or something like this.
Currently, we don't actually have regular bandwidth throttling, but usually, mostly people use Process Max to do throttling. So it really depends on how many, because almost everyone's doing compression, and compression is one of the big bottlenecks. So usually it's a matter of how many cores you decide to throw at the problem. So it's a bit of a rough and ready kind of throttling. We haven't implemented, regular like just output bandwidth throttling yet. It just hasn't been a big ask. Most people have a certain amount of CPU resource they're able to dedicate to backup. And then if you want things to use less bandwidth, you can also increase the compression. There's lots of ways to tweak how much output you're producing. So it's been an ask, but it hasn't been a huge ask. And we've got a long list, so we need to prioritize, of course.
I can imagine. And what is the good? I see in your README you mentioned 1 terabyte per hour, like a good speed of creation of backup. Is it still? It's pretty old. So what is a good number you can observe on some production setups right now?
The reason why we've left that there is that it's a reliable number. It's a number that almost anyone can achieve on virtually any hardware. So if you're not getting to a terabyte.
So if you have less than 1 terabyte per hour, it's bad. Go and fix it, right? So,
you probably, with modern hardware and networks, you should be able to get to 1 terabyte per hour, even on a primary, even if you're backing up directly from the primary. So that's a very achievable number. The biggest numbers that we've seen out there, not the very biggest numbers, but the bigger numbers we've been seeing have been between 4 and 5. And then a lot of this is, and a big thing that's changed is for a long time, we only supported gzip. But this year we've introduced 3 new compression types. And especially with LZ4, the throughput of LZ4 is phenomenal. And so if you want fast backups, you're going to use LZ4. But then the question is, can you actually push that much data through your network? And increasingly, more and more people, when we started this project, we were backing everything up locally. And then for the first several years of the project, it was very much the same thing. But in the past 3 years, I'd say there's been this huge change where most people are backing up to object stores, even if they're local object stores, right? It might be something like MinIO you've hosted locally or IBM object store. I mean, there's a ton of S3 compatible object stores out there, including Swift. So a lot of people are using this and they're either backing up to object stores or backing up offsite, and throughput can be a problem in those cases. So if you're using LZ4 and you're getting this, theoretically amazing throughput, you might actually go to the host and find out that pgBackRest is using 10% CPU per process because it's simply not able to push, the data out. And we've done a lot of stuff with async, writing things asynchronously, and that we've done a lot of work to try to make things run in parallel and run asynchronously to make improve throughput. But ultimately, this stuff has to be written to disk someplace, somewhere, even if it's in the cloud, right?
And speaking of clouds, as I understand, pgBackRest doesn't support Google Cloud right now, but supports Amazon and Microsoft, right? AWS and Azure. Okay, and since I was dealing recently with issues on Google Cloud for Volg, I have a question. So if Object Store has some quite tough logic in terms of error, for example, errors can happen like 502, 503 errors, right? And we are dealing with quite large files in Postgres. Uncompressed, it's 1 gigabyte. Compressed, probably like 2-3 times less, right? And we are going to upload it. And if for example, object storage started to throw 5x errors, right, to us, and for example, Google Cloud has a policy 32 seconds. After 32 seconds, you should consider this this backend as dead. So you need to restart the whole process. And this means that you need to keep whole file in memory and restart it fully, or you can deal with some kind of you can continue where you started. Is it possible? Like, have you had some kind of?
So the answer is we do both.
Okay.
There are basically two types of major errors you're looking at here when you're dealing with something like the cloud. You've got transient errors, where let's say I'm doing multi-part upload to S3, and I'm uploading one particular part, which I have in memory, right? Because I'm uploading that part, I have to upload it as a whole to S3. So I'm holding that part in memory, and I may have uploaded previous parts before.
And the part is quite small, right? Right. It's kind of this part is small.
Our buffer size is a megabyte. So at that moment, but S3's minimum upload size unit is 5 megabytes. So at that point, we'll be holding 5 megabytes or maybe less of data. So we're going to be holding that. We try to send to S3, and S3 gives us some kind of transient error. It just says, please retry. And this happens all the time. If you're not doing some level of retry, you can't really do a single backup to S3, because you will always get some. I mean, you might make a backup if you're lucky, but there are always these retry errors where the host just goes away, something happens, and so we do a retry. Then there are bigger retries. For instance, on Azure, Azure can basically get to the point where you've already uploaded multiple parts, and it's going to say, no, I've lost everything. I'm sorry. You can't do this. So now we're in a bit of trouble, because those previous parts that we had compressed and transferred to Azure are lost by Azure, and we don't have those in memory anymore. So in that case, we do a big retry where we actually go back and retry the entire file. Really not a lot of choice there, unfortunately. Now, these are, if you're doing an Azure backup, let's say it's a 2 terabyte backup, you will see this type of an error maybe one time. The full retry where it says, I lost all the parts, you need to start from scratch error. And it's pretty rare, but it does happen. So if you're looking at terms of your total throughput, are you going to notice it? No, you're really not. But if you're not handling that case, then the backup will fail, and that's the end of the backup. So we basically have those two levels of retries. We've got the transient error retry, and then we can just repush that part. Those are pretty common. Those happen a lot on every service.
Yeah, I've checked SLA of Amazon and Google, and I was surprised to see that EBS volumes has better SLA in terms of this error rates. But
the deal is you're getting what you pay for here. I mean, the storage is extremely cheap. But your software needs to be more resilient than maybe normal software would need to be to take advantage of that cheapness.
Also, S3 main purpose is not to lose data. They focused on not losing data, not on error rates when you talk.
We're worried about transient errors. Yeah. So we handle both of those cases. Having to retry the whole file is not great, but the nice thing about Postgres is it's chopping files up into relatively small chunks. Right, so 1 gig is the maximum size file you're going to see that you have to retry. That's not terrible. We're not talking about a 1 terabyte file that you have to do a retry on, right? So yeah, we do a lot of retries because networks are noisy, and these object stores are noisy, and you just have to deal with that and be prepared to do these retries. So this is one of the things where you come to the advantage of us having implemented, having our own TLS implementation like Postgres, and being able to write these drivers. We can build in all the async logic we want. Like everything we do is based on performance, 100%. We're trying to go as fast as possible and be at the same time completely accurate, right? This is why the very first version of pgBackRest 0.1 had the manifest code already built in at that time, because having a backup without a list of all the files and their checksums is, well, it's dangerous. If you lose a file out of there, how do you know it?
You can make a backup. You probably could not restore.
Right. So the question is, what do you have confidence in your restore? Right. You need some way to check them against each other. So we have the manifest with the list of files and all their checksums, and then the manifest itself is checksummed. So if the manifest is modified, we'll know it. And if one of the files is modified, we'll know it. Now it sucks to get a restore where you get a failure on a restore, and we have seen it sometimes when there have been IO errors in the kernel and stuff, and we get a successful. We're told the write was successful, and there's corruption on disk, and you try to do the restore, and backrest won't do it because there's a checksum violation. But that's why you have multiple backups, right? You never want to be running with one backup. If you get a backup restore failure, you go to a previous backup.
It's kind of interesting. So
am I still live?
Many
not.
people who do
You've
You are still, your
Freezing.
audio is still on. I'm not sure what happened.
slightly freezing.
Yeah, it looks like you were freezing. I did want to kind of jump in on that though and make a comment on that. So we are looking at adding support for Google. It is something that we're going to do. I can't say exactly when, but it's definitely on our relatively near term roadmap. And we will absolutely have all of that same kind of retries so that you are going to be very likely to get a successful backup with pgBackRest, because we're going to have those transient immediate retries for the smaller chunks, as well as the full file level retries when needed.
Right. The transient retries are actually built into our HTTP layer. So if we get a retry message from the service, then we automatically retry it. The driver doesn't even see that retry. And then at the higher level, the main backup process actually starts up a bunch of other processes, which we call locals. And the locals actually do the work. So they get a job. The main process says, here, back up this file. This is your job right now. And so that process will just automatically retries things that fail. So it'll catch any exception that bubbles up from the driver from wherever. It doesn't matter where it comes from. The local process will say, at the top level, will say, oh, I got a failure. Let me just go ahead and retry the entire job from scratch and see what happens. And it'll do that a couple of times, right? It doesn't do it forever, but it's got 3 retries built in at the top layer as well. And it's got a bit of a back off too. So it'll do the first retry immediately. And then it waits like 5 seconds, and then it waits like 15 seconds. Just so if there's a network blip, it might be able to get past that. Eventually it will give up. But yeah, all those retries are actually not in the drivers, the storage drivers themselves. They're under it and above it. Sorry, now I'm on camera. So retries are here, and the driver is in the middle here.
Right. We also noticed for Google storage driver doesn't support, they call it composite objects. So it's like a multi-part upload. So the driver for Go language does not support it. And
it's one of the reasons. It's one of the reasons why we haven't dealt with GCS yet, because they've made multi-part upload such a pain. Yeah. But we're going to have to deal with it. And like I said, one of the nice things about having our own drivers is that we can support anything, and we can do it performant. So we won't be in a situation where we're using, like, say, one library for S3, which is really mature and fast, and then one library for Azure, which isn't very mature and isn't very fast. Our Azure and S3 implementations are, those performances only affected by how fast Microsoft and S3 will go, because the implementation and the asynchronous logic we built into each of them is essentially the same.
We have lots of questions.
So because we are now on the extra time, we need to try to go through, because I suspect we dig one question and it will cause some sort of drop cascade
discussion. Long discussion. So there are questions about incremental backups.
So what's an idea? What's an architecture about your
avoid full backups daily, do only part of the job.
Well, what I prefer actually is occasional full backups, generally weekly. And then what I like to have is a rolling set of differential backups that kind of go through the week. The nice thing about differentials is because they only depend on the full backup. So a differential is an incremental that's based on the full backup. That's all it is. It's a special type of incremental.
You don't. There are 2 terms: incremental and differential.
Right. So incremental is based on the prior backup, whatever it is, full, differential, incremental. Right. So you can get these kind of long chains of incremental backups, and it's hard to expire things in that chain because there's dependencies all the way down the chain. But with the differential is always based on the full backup. So you can independently expire differentials whenever you want, because they don't depend on anything except themselves and the full backup. So what I like to do is I like to have a weekly full backup and then a rolling set of 3 daily differentials, through the week. So by the time I get to Wednesday, Thursday, Friday, I've already expired the Monday, Tuesday differentials. I don't need them anymore. What that does is it gives me 3 days of good coverage where I can restore a backup within the last day and minimize the amount of wall replay that I'm going to do to recover. Right? You really want to keep that recovery time as low as possible. Right? This is your RTO. So by having recent backups, you can keep your RTO as low as possible. Our PO is really a basis, dependent on, how much wall you have. Like if you have a standby, your RTO and your RPO are going to be essentially, as long as the standby is up to date. I mean, that's key. but they're essentially going to be almost zero. If you're working from a backup, then they're not going to be zero, and your RPO is going to depend on, has everything been archived? If you lost that original primary, where were you when you're archiving when that primary went down?
If we archive,
the way you manage that though is through what's called archive timeout, right? So you can actually manage that with your RPO and keep it to within a minute or whatever you need through archive timeout. That works really well.
And in most cases, we are going to use the primary to archive walls, not secondary, right? To reduce this metric.
Right. Yeah, we always use the primary for archiving today. We've had some discussions recently about allowing the replica to be able to do archiving as well. The idea behind that usually is to go to a separate repo though. And so that's something like if you have two different data centers and you have a primary and a replica data center and you want to have wall archiving from both that are going to two different repos. So the multi-repo support that we're working on right now is kind of the precursor, like it's the beginning step to get to a point where we can support that as well. So that's something that we're currently working on right now, actually.
Another part of this question, actually, how these increments are implemented. Could you describe this in a couple of words?
So is full scan needed, or like of whole PG
do you
data?
need to scan all the database, or you're tracking some things on the block
level? With incrementals, I think I can probably do this pretty short, right? So incrementals are file based. Right, so we don't yet go down to a block-based type of incremental. We've looked at that. It's something that we will probably get to eventually, but right now it's on a per file basis. And the way that we check to see whether or not a file should be included in the incremental is to see if it's been modified since the beginning of the last backup. Right, so that's what we're looking at to avoid. There's some race conditions in there where if you don't do it carefully, you can possibly miss that a file was changed like in the middle of a backup or right in the same second as the backup started kind of thing. So we actually check and make sure that the last time that file had changed was before the beginning of the last backup. And that's kind of the default that we use. There is an option, as I recall, to have us also do a checksum of the file to make sure that it hasn't changed since that backup was taken.
We also have some heuristics in there because we're essentially trusting the modified time, right? So we also have some logic in there to say if we see funny things with modified times in the database, like if we have modified times in the future, or if we have modified times that have gone back in time from where they were on the last backup, like we have a whole list of things that if we see them, we'll automatically turn on a checksum backup and warn the user. We'll say, hey, we're seeing some really funny stuff here with your modification times. These things should not be happening. So we'll switch to automatically switch to the checksum delta. We also do that in some other cases, like if we see a timeline change. If you have a timeline change, that usually means you failed over to a standby. And that means the timestamps are totally untrustworthy at that point, right? Because the standby could have completely different timestamps than the original primary did. So when we see that timeline change, we're also going to automatically put you into a checksum, a backup as well. When these things happen, they'll actually come out as warnings in the log. So you'll see them. If you're running off a cron, you'll just see them in an email too, right? And so we'll switch to that checksum delta whenever we see anything that looks a little bit funny. But as Stephen said, the incrementals themselves are file based. Generally speaking, we found this to be a perfectly acceptable solution. We are looking at page level backups, but there's just so much stuff that's still higher on the list. That people we feel like people need more.
If I have backup, for example, in S3, is it possible to have like redundant backup in another cloud provider, like to copy it somehow?
So this is what Stephen was talking about. We're actually working on this feature.
Not fully, because Stephen talked about backing up from a replica in different region.
He did allude to something called a multi-repo support, which we're actually working on right now, and we will be releasing fairly soon. In the first version of multi-repo support, the only command that's going to be 100% multi-repo aware will be archive push. So that'll mean that when you're archiving from a server, it'll automatically split. It'll compress it once, but since we do everything in memory and we're streaming, we basically do the compression block by block, and then we send it 2 different directions. One direction to S3, one directory
from the same
direction to
machine,
Azure,
right? Where we
from the same machine.
Okay.
Right. So it should be quite fast. It'll basically be as fast as your slowest, I/O. So if Azure is slower than S3, then it's going to be as fast as Azure, right? Because it's going to do the compression once and then split it, block by block, and then it's going to send it both directions asynchronously, and then wait for responses. So, it should be quite fast. But then for the other commands, for instance, if you want to do a backup, you're going to have to tell it which repo you want to back up to, which is actually, we do multi-repo stuff now. It's a little complicated, which is why we don't want to make a big deal of it. We're trying to make it like a really packaged solution. But usually when we're doing multi-repo support, you really want the backup schedule to be different anyway, because you might have like a couple of full backups and a couple differentials in what I call your nearline repo, the thing that's in your data center with you. That's where you do most of your restores from and you feed your replicas from. But you also want some, say, weekly backups off in S3, but you want to keep a longer retention on those. So your backup schedule tends to be a bit different anyway with the different repos. So backing up directly to multiple repos maybe that will make sense, but right now you'll have to tell backrest, back up to repo 1, back up to repo 2. And when you're doing a restore, you'll have to say a restore from repo 1 or restore from repo 2. But in the future, like right now, we're able to select the best backup for you based on what time you give us. So you say recover to this time, and we go find a backup for you that'll give you the shortest RTO to that time, right? In the future, we'll also be able to scan multiple repos to get that. We might have to have some kind of costing factor in there to know that certain repos are going to be slow to restore from, because they're S3 or whatever. But those are all the direction we're going to go. So the initial support will be archive push, which is the most important thing to have multi-repo. And all the other commands will be multi-repo aware. So you'll be able to tell it, go get something from this repo, do this repo, get info for this repo. And then over time, we'll build those out. And each command, the way it deals with multiple repos will be different, right? They're not all, with archive push, you just want to push to all the repos, right? Full stop. Right. Make as many copies of this thing as you can. That's the goal. With other commands, the goals are a little bit different, and we'll work those over time.
I'm not sure I would choose the project if it would be possible. If it was possible, maybe I would choose pushing as fast as possible to repo 1, and then somehow mirroring in repo 2, not to depend on the speed of the second repo.
Agreed. So, especially as I've been writing the code, I have been thinking about that. But what we really like to do in these cases is get a decent implementation out first. Right. So this may not be the best implementation for every use case, and it may not be overall the best performing for every use case, but it will work. And then we start adding, then we tweak things. Then we think about, well, what's the use case of, just like you said, where I want to push to repo 1 as quickly as possible, and then I'll replicate to repo 2 when I get the chance. And that'd be an additional feature that we look at in the future.
It's certainly something that we've been thinking about already of kind of a backup copy option. That believe me, we've thought of that, and yes, we'd like to get there, but it won't be there for the first iteration, but we will add it. Yeah.
I see. Thank you for explanation. Another question related to clouds. What do you think about using cloud snapshots instead of full backup, or incremental, or
so
like?
Why you do need pgBackRest for clouds anyway?
So the thing with that is that you've got a couple of challenges there when you're talking about taking snapshots. The first is, as we talked about before, do you really have a backup if you don't have a manifest that has the checksum of every file you've backed up, right? So right there, you're already saying, okay, well, if we're going to get backrest involved in doing snapshot-based, we probably would want to have some way to go and get the checksum for all of the files that are in the snapshot, right? So that we can build a manifest, so that we can have some confidence that when we go to restore this thing, it hasn't changed out from under us and is still valid, right? So that's one of the areas that we have thought about. It's not something that we've really spent a lot of time looking at implementing, honestly, but is something that we've considered. The other aspect of that is that a lot of times, if you're taking these snapshots, how many copies of that data do you have now, right? The snapshot, if it's still sharing the original volume with the primary, right? And what happens if that volume ends up going down? And okay, well, I've got all the change blocks from my snapshot, but now I've lost some of the blocks out in the middle, right? Because I've lost something there. So that ends up being a downside. And one of the reasons why you have full backups, multiple full backups, is that you have multiple independent copies across different storage mediums of your data so that you're not likely to lose it, right? And that's an important aspect of backups in general.
An interesting data point we've seen recently is that one user, a community user, wants to replace their LVM snapshots with pgBackRest because they basically found pgBackRest was significantly faster to do restores than recovering a snapshot. In their case, it was about 8 times faster to use a pgBackRest Delta restore, because one of the things we have is that manifest, and that gives us a lot of power to make the restore extremely fast by scanning the current backup, this current files, and pulling in only the changes that we need. So they're basically replacing a snapshot-based system with pgBackRest in order to get that performance.
Cool. Yeah, yeah.
But we're not discounting using snapshots. We have had many discussions about how we would do this and do it safely and make it make sense and all of that. So it's not something we're not considering. But in order for us to do it, it have to be safe and correct. And
yeah, it's not that simple question as you
it's
can.
not.
Yeah.
So we almost run out of time.
Yeah,
So may I
already.
actually abuse my right of co-host and ask you both one after another one short question, probably short question. I don't believe personally the answer would be short, but it would be like interesting. So you are developers of pgBackRest. Just forget that you are contributing to Postgres as well. Postgres is as it is. It's a project with history, with some architectural issues, which could be good, could be bad. As a developer of pgBackRest, or backup solution for Postgres, what would you wish to be made differently in Postgres? Are there such things? Like, Steven,
Yes.
I see you probably would.
I was like,
yeah, the short answer is yes. There are things that it would be nice if they were different in Postgres that would, I think, make backups go a little bit more smoothly and a little bit easier. Now, as it turns out, in pgBackRest, we've actually ended up solving a lot of those and working around them. Things like the entire archive command interface kind of sucks. I mean, that's just a reality, right? Execing out to this other program to run a backup is not ideal. We've actually had discussions, David and I and Magnus, about, maybe we could have like a library loaded there or something. But at the end of the day, because we rewrote pgBackRest into C, it's become much less of an issue for us because in the C code in pgBackRest, we're fast enough to keep pace with being called by archive command a whole bunch. It's still something that's kind of back of mind as something it'd be kind of nice if we could do this as a library instead, but it's not as big of an issue. So anyway, all right, I'll let David. I think David's probably got some more interesting comments in this regard.
Yeah, so sorry, there's a question from chat, very related. So why archive command, not while streaming? Like Barman had it long ago, the idea like let's use a replication protocol for backups.
So I think there's a couple of answers to that.
What a mess. Sorry.
I'll share my part first, right? I would say that, in that case, you need to have that process connected and running constantly. And if you don't, there's some risk that you're going to lose data. And there's also risk if you don't have it connected that you're going to end up filling up your disk, right?
But there are slots.
If you're using like replication slots, because and that's something I actually discourage is using replication slots because you don't want to have these, but you don't want to end up in these situations where your primary could end up with a whole bunch of storage ended up on it. But it's just a matter of adding in a lot of that complexity to gain. I think there's some question there about how much you really gain from it, from my perspective. I think there's kind of this one other aspect that we're thinking about, and right now, pgBackRest, if it's going to have a remote repo, is usually going to be SSH based or going to some of these cloud options. One of the things we have talked about is building a server mode into pgBackRest, where we can have an always running server that we then talk, because we actually have our own protocol built over top of the the SSH that we use right now. It's actually the same protocol we use between the main process and the worker processes. So we've talked about building this into pgBackRest as a full service that's running and is a destination for your backups to go to. That would be talking, it basically talk TLS, right? And you would use that instead of SSH. That then does go and involve all of the authentication challenges associated with that, though. You have to make sure you're doing proper authentication and verification of that, which we currently leverage through SSH. So there's some trade-offs there, but it is something that we've considered. So anyway,
one more thing that Stephen didn't hit is the performance of streaming replication is horrendous.
Yeah.
There's no compression. So you're basically throwing all that stuff uncompressed over the network serially. We think in terms of parallelism for everything that we do, right? It's always, every time we build a new command, it's like, how do we do this in parallel? And we have standard mechanisms for doing that, of course, at this point. But the biggest issue for us is performance. pgBackRest is used on a lot of small installations, but it's also used on a lot of really enormous installations where streaming replication, we actually have a lot of users that use pgBackRest as a form of replication because there's no way they can keep up with streaming replication. It's impossible. So what they do is they just rapidly take and restore backups all through the day to keep their replica within a certain distance of the primary, right? To keep their RTO as low as possible, but they simply cannot do replication. So our focus has been on that performance aspect. But this is an area that, the real-time aspect of keeping your RPO as low as possible is something that's a bit of a weakness for this technique and something we are definitely planning to address and make that a little bit tidier. Absolutely. And to Ilya's question, was that backup specific stuff in Postgres or just Postgres itself?
No, well, both actually, but we focus on backup stuff. Yeah.
Oh, okay, right. Well,
I would say on infrastructure, which you try to use developing pgBackRest and hit some problems. The good example is from Stephen. It was a hive command. Yes.
I think one of the big things that I would like to see, and this applies to everything, is really, the level of unit testing we do in pgBackRest is more than, really almost any other project I've seen. And I'm not necessarily saying every project should do that level, but we've found unit testing to be incredibly valuable to find dead code, dead conditions, things we never thought of. It forces us to exercise and examine the code to a level that, you just find stuff that, bugs before they go out. We find a lot of stuff that we go, oh, and they're not always necessarily coding errors. It's sort of an error in our understanding of how something should work. And because we basically have to code it 2 times, we write the actual code and then we write a test to exercise it, we're forced to think and rethink, how does this feature actually work? What does the interface look like? How is it being used? And so not only are unit tests great for regression and, testing on different platforms and different architectures, we test on 5 architectures now to try to broaden our, our testing pool, but it forces you as a programmer to really think about what you're doing at a deeper level. So the value of unit testing, I think, is underestimated in that regard. And that's something that when I'm working on Postgres stuff, so when I put on my Postgres hat, I get a little frustrated that I don't have the ability to test down to that level. We do have coverage reports, so I can go and see what my coverage is, but I'm poking at Postgres from a really high level, right? I've got to go through the main interface to get any testing done, with this expect testing, whereas what I really want to do is poke at the function and make sure it does the things that I want it to do. And we don't have that ability right now. We've talked about it, but we don't have it. And that's one of the things that frustrates me when I'm working on my Postgres code, is not having that ability to test at that low level.
Yeah, interesting. Thank you.
Welcome.
So we almost run out of time.
Last question. Last question.
Uh-oh.
He wants to abuse his right to.
Right. Very small.
I'm going to need a beer here soon.
I know.
Well, yeah. Very, very small question. Dumps are not backups. Do you agree or no? If and why?
I agree that dumps are not backups, and I would say that because you don't have point-in-time recovery is a big aspect of that, and not to mention that your recovery time trying to restore from a PG dump is forever, right?
Yeah.
In comparison to
if it's a big database
restore.
I would say it a little differently. I would say dumps are backups, but they are not a backup solution. Right. So they represent a point in time backup, and it can be useful. And being able to dump, individual tables out and things like that, clearly that has value. But a backup solution is doing validation and verification of the backups, it's doing rotation of the backups, it's handling wall, which in the case of dumps, you don't need to do. But there's a lot more to a backup solution than just creating a backup. Right. And that's one of the areas where I think pgBackRest really shines, because we've always focused on all aspects of a backup solution. What does it mean to be a backup solution, and what do users need beyond just having a backup on disk? You can have a backup on disk, but you can't verify that it's correct, or you can't find it, or you can't, figure out what the date it was taken on, all these sorts of things. It becomes useless or less useful. So a backup solution is different than a backup. And pgBackRest is a backup solution, and there are other backup solutions out there. A dump is just a backup in isolation with no context. It's
logical.
It's quite a different thing. Yeah,
logical, not physical, right?
Right. There's that aspect of it too, but really it's like talking about the whole backup as an ecosystem, all the things you're going to use backup for feeding replicas, for building replicas, for dealing with disaster recovery, there's so many things that you can do with backups and archives. Like Stephen said, if you have a good archive, you don't need replication slots at all. We've had customers that have been mystified that their streaming replication went down, and when they figured out their standby was up to date, and they didn't know why. Well, of course, the Postgres will immediately switch over to pulling stuff from the archive if it has an archive, and it does have communication from the primary. So their streaming replication is down, but their standby is reasonably up to date. How did that happen? It's magic. Well, it's a backup solution, not just a backup.
Right. Interesting. It was very interesting. Thank you so much, Stephen. Thank you so much, David. Very interesting.
Thank you for having us.
I'm sad we didn't cover very important topics like corruption checks and so on. But unfortunately,
as usual, we probably need to make a second episode
follow up
at some point.
We would be open to that, to talk about more advanced topics, because you had a lot of interesting stuff in your outline, but it's just it was a lot of stuff to cover.
Yeah.
Cool. Thank you so much. Thank you. And thank you all who participated in chat. It was very active, and who will watch later. Don't forget to subscribe, press bell button or something, like or dislike. I don't know.
and I would put a small spoiler. So next episode, the episode 4, is already scheduled. I will not say what it would be, but it would be interesting. It would be more, I think, in direction of development. So keep.
Let's see. Yeah. We will not disclose it right now. Okay. Thank you so much. Have a good day. Have a good rest of week. Bye bye. Thank you so much.
Thank you. All of you.
Thank you.
Thank you.